Number 6, taken from the PastPaper C2 Jan2011, an integration question. Complete the table below, given that y, given the values of y in 2 decimal places, and the function is given, which is y equals 5 over 3x squared minus 2. Now, in order to complete the table, we take the values of x and we replace them in the form or in the function. So y is equal to 5 over 3 multiplied by 2.5 squared minus 2. You plug in these into your calculators and you will find that the answer is going to be 0.30 to 2 decimal places. We do the same thing for y equals 2.75 and the answer is going to be 0.24. In part B, use the trapezium rule with all the values of y from your table to find an approximation for the value of the integration bounded between 3 and 2 of y. So we are actually finding the value of the integration which is bounded between x and x2 and x equals 3. This is what we are actually finding the approximation of. So you have to be careful because we're going to use that later. In order for us to find an approximation, we use the trapezium rule, and the trapezium rule is equal to, or approximation of, 1 over 2 times half. Let me write it here. So it's 1 over 2 approximation, 1 over 2 times h multiplied by y0 plus yn plus 2 times y2 y1 plus y2 plus y3. Let us pinpoint first the formula or the variables. A is for this one, B is for 3, and naming them, it's y0, y1, y2, y3 and y4. So now let me continue writing the formula. So instead of yn, I'm going to write y4, because now I know how many y's we have, and then I close brackets here, and my formula is complete. Regarding that, h is equal to b minus a over n. So we already defined b and a, so it's 3 minus 2 over n is the number of strips minus 1. So 1, 2, 3, 4, 5 strips. So you have n equals to 4. So the answer for h is 1 over 4. So we replace all the values that are in the table in the formula, and this is what you get. Then you try and replace all of these numbers in your calculator, and you get 0.32, which is the approximation of the area which is under the curve bounded by 3 and 2. We continue. Figure 2 shows a sketch of part of the curve with equation y equals. Add the points A and B on the curve, x equals 2 and x equals 3 respectively. So the x of A is 2, we don't know the y, and the x of B is 3 and we don't know the y, but we should know the representation of the y. If you want to find the y of A, you go to the table where x is 2. This is the y of A, so 0.5, and the y of B, you just draw the line parallel to the x-axis to get the y of B, and when x is 3 in the table, the y is 0.2. So this is how we find the y of A and the y of B using the table. They want us here, the region S is bounded, so we have the region S now, is bounded by the curve, the straight line through B and to 0, and the line through A parallel to the y-axis. So the region is bounded by the line here, which is x equals 2, and by this line, and by this curve from A to B. Use your answer in part B to find the approximation or the approximate value of the area of S. So in order to find the area of S, and we already have the area which is under the curve, we only need to find the area of this triangle. In order for us to subtract them from each other, we get the area of S. So in order to find the area of this triangle, first, this is a right triangle, so we can say that the area is the base and times the height. And the height here is the y for B that we already found. So you multiply half times 1, because 3 minus 2 is 1, which represents this length, times the y of B, because it represents the base, and the answer is 0.1. And we already know the area which is under the curve AB, all of the area found from the trapezium rule that we used. So the area is 0.3175. This is what is shown on your calculator. Remember, this is the approximation here. So this is the actual calculator value minus the answer that you found for the area of the triangle. You will get 0.02, which is the area of the region S.